All right, after that rather long like redo of doing everything as a command, let's move on to the next thing. So wouldn't it be nice if we could ask what the person's name is? Let's make a program that does that. Let's say, I don't know, let's call it prompt. Okay? Let's call it prompt. Now, the command I'm about to write can be done as a single read command. I'm kind of doing this on purpose if you know about it. But let's make a new program again. So let's call it prompt. And let's schmox it. So now we have a program. I can do user bin bash. I know this is crazy, right? But the sipping was so nice. Sorry about that. I did schmox. I did schmod plus x. It's an alias. We made it last time. So, whoopsie. env bash. All right. And you can exit out and reopen it if you want. All right. Now, what do we want to do? We want to say something. Something. And then we want to read in one line of input. And so the way to do that is read. And we're going to say line, right? And then we'll just echo that line back out. All right. Now, shell check is screaming at me because I'm doing a bunch of things that are bad. So one of the things is whenever you read a line, you should do -R so that backslashes will be dealt with properly. It's kind of, you just have to do that, right? Line is a variable that's going to be put into, and then we're going to echo the line. But to be safe, we're going to wrap it in double quotes. Otherwise, shell check will just scream at us. All right, so that's our program. That's it. That's all that's in the program. Now we can run prompt, and we can say, okay, something, hello there, right? And it prints it out. So now why would I ever make a thing like this? Well, watch. Okay, so let's put like that there. It's like, we could actually just put a question mark, and we can say prompt. I'm getting ahead of myself. Prompt, you say, oopsie, why is it putting a new line? Well, let's not do that. Okay, so let's do that. Let's do, it's echo. Well, we don't want it to do a line return, so we do -n. Okay. Now you could do this with printf, and it would take care of the same problem. Might be better to do printf later because we're going to put color in there. Yeah, spoiler. So now we have hello, and put enter, right, and it prints out the prompt. Now let's keep going with this. Let's change it to printf, and let's actually put some other color in here. Now you can do this with read. So before we get too far along in here, read has another thing called p, and you can put the prompt in there if you want. All right, but it doesn't do replacements and stuff. And I'm not a fan of that. I'm always a fan of just prompting ahead of the time and just having read only do one thing, which is read the line. In this case, so let's go back to printf. And now when we have a printf, we have a bunch of things we have to do here. So let's say I want it to be a question mark, and prompt automatically doesn't, printf doesn't put a command a line feed unless you tell it to. So we're gonna say just print that out. But I want to put some color here, right? So what do we want to do we want it to be black? What do we want the prompt to be? How about magenta? So we put S here, and we can do magenta, which we don't have yet, but we'll go ahead and add it now. You might not know this, but term colors is a program that just prints out the terminal colors, so I can go find them and keep them in my program. So, and I just filtered it and put it in there. So now we have magenta, and we have a magenta prompt. And we have a magenta, but now the whole thing is magenta. I don't want the thing they're typing to be that. I want the thing they're typing to be like gold. I want it to be really fancy, right? So let's do that. Let's put another one in here, and let's make this one yellow, right? And I happen to know that yellow is, I think, 32. So, whoops. So we change this to yellow. And now we can do that. Prompts. Hello there. Wait, I guess that's green. Wrong one. Maybe it's, I don't know. Which one is it? term colors. Whoops. Term colors. Yellow is 33. Okay, 33. All right, so now when you do it, prompt hello there. All right. Ooh, that's nice. But you see how it the color was bled? The colors bled into it. Well, we need a reset. And I know the reset is 0, so we'll do a 0. Oops. Reset. And we'll do a reset. Oopsie. And so after they type their prompt in, we will, print a reset. Actually, the reset has to come after they type. So we'll put it after echo reset. Actually, we just do another printf. No. Echo dash n reset. That's just like no line return. And then it's gonna, well, no, we want that. We definitely want that. So prompt hello there, enter, and then it prints out the word. Okay, why do we want the word to print at the end? Why do we want the word to print at the end? So we're going to use a trick here. Yeah, we're going to use a trick. And we're going to actually do something different. We're going to say, let's see if this works. This might not work. I want to try it first. Let's try it first. We're going to print for 2. We're going to print 1 goes to 2. And you're like, what the hell is up with that? And I want to show you this. So it might not work. Typical human behavior. I don't know. Prompt hello. All right, now, so okay, it's a trick. I did a trick. I'm doing a trick, and I want to show you why I'm doing a trick. It looks the same. It's not. It's not the same. Let me show you why. Because the output from this is going someplace else. What does that even mean? Why is that a thing? Because watch what happens. If I say, let's say I want to say, hello, whoops, hello prompt, right? It's like, what is that going to do? Rob, you see what it did? Like, think about this for a second if you don't know what happened. Okay, so why did it print my name out properly? Right? So now if I hadn't done that, yeah, watch. If I don't put the redirect there, what's it going to do? Now what's it going to do? Nothing. You see what it did? I want you to pause the video and understand what just happened. Okay. There are 2 streams of output in Bash, or anything really. And one of them is standard error, and that's kind of throwaway. And we regularly redirect that to dev null and things like that. And the other one is standard output. And that is significant. Standard output is something you should always use. You should always capture. And printing error code and informational logging and all that stuff to standard error is a bad practice. It's an anti-pattern. So don't do it. And in this case, the prompting to get something new went to standard error. And so we were able to get that. And we did a thing here. This is the first time you've ever understood anything about redirecting standard output and standard input. So I wanted you to see the difference. Okay. Now we're kind of leading into like, how do I write stuff to a file and things like that? But the only thing you need to take away from this right now is that standard output is number 1 file descriptor, and standard error is number 2. So what we said was, by default, everything prints out to standard output. And so we said, instead of printing to standard output, print to standard error. Redirect standard output to standard error. And by doing that, it didn't impact, so we were still able to capture the output of standard output and use it. Otherwise, as you saw, you would get this problem where it would put the prompt, because the prompt was not print to standard, it was print to standard output. And I don't know if you noticed, but it didn't even put the prompt for us. It didn't even show us the prompt, right? So this is kind of an interesting little trick. And I feel like it does kind of give a sense of like how to use standard input and out and error for fun. So you could say, hello, you could say, Rob, right? And let's actually change a little bit. Now there is kind of a quirk here is still happening. So you can see that the prompt itself is got a problem, right? Why is it still colored? Well, it's because we only redirected one of our things. We need to redirect this thing too now, right? That's why hello is gold. So if we do that, this should take care of it. Let's try. Yep, there we go. Okay. So the thing that's really cool about this is you can now inline prompting for different things as you're going along. And that's kind of fun for when you're making all kinds of things. So this is the actual output, right? Actual output suitable for consumption. Yeah. Tell me, so why didn't it show an error? Just now, I got a hiccup. Yeah, there's been some frame drops a little bit. Send to stud error. Send to stud error. Capture stud in. I wonder if it'll sync. Yeah, good. And then there's an actual output suitable for consumption. Okay. So is it prompting absolutely an anti pattern? We're just making, they're just learning about stuff. Yeah. Bash script should never prompt. Right. You should never, this is where you know what, Cookie, you're right, but this is where I have trouble, right? Because a lot of the ways I've been teaching this stuff, like we're going to do Magic 8 Ball, interactivity, and it shows somebody on YouTube and Twitch is rightly saying that you should never prompt in any bash script, because what you're doing is you're forcing your program to block. And so what that means is that if you combine your script with another script in some form of automation, that it'll block and it'll stop working unless you it's waiting around for somebody to interact with it. And the best practice, which is absolutely true, is to not ever ask for interactive input. The best practice is to require environment variables to be set to run. And if they aren't set, to prompt for them or to do prompting, you know what I'm saying? So, that is a very fair thing to say. That said, however, on occasion, it is fun to make an interactive script. So we're going to make a Magic 8 Ball program, and that's what we're kind of leading up to. And, if you have an interactive terminal UI program, then, that's a different context. It's a different use case. And that is largely where most of my content has been evolving around interactive story game, thing like that. But if you're writing a script for production that needs to run, you should never interactively ask for something. You do not understand how it helped. All right. Well, let me show you what happens if we don't do it. I want you to watch the difference. Okay. So if we change this, let's take our program here. All right. Let's comment this one out. CMT. And let's run it this way now. I'm going to get rid of the redirection, and I want you to look really closely at what's happening. It's really important that you understand what's happening, because if you don't understand, you won't understand the nature of capture things. All right. So look at this program. So what is this programming doing, right? It's it's saying hello, and it's using a variable, but that variable is it's kind of a weird thing, right? But I'm doing it kind of, I just to illustrate a point. So when this runs, it's going to block. Now I could have put name here. Yeah. GH prompts for sure. Yeah. There are many cases where prompting is totally fine. So yeah, it's the right, you just know that it just depends on how your thing is planning on being used, right? But in this case, I put prompts, right? So I tape Rob here. All right, what did it do? All right, so I I want you to look at that output really carefully, and then I want you to say, I want you to see what is going on. Okay. Do you see it? Do you see what it did? So it took the output. So we printed out this prompt here, right here. We printed out this prompt right here. And what happened? It printed out and it got added into, it got echoed out, and then it got lined. Now, why was that? The reason is because the prompt, as well as the reset and this line right here that echoes the input, all got printed out to the same place, standard output. I don't know if you noticed, but when I ran this, it didn't even show me the prompt. Why? It didn't show me the prompt because it was waiting around to give me the output. So again, when you call a program like this, what it does is it captures the output of the program and replaces it and uses it as a variable. So, if we had put the date there, right? So let me give you let's revisit this a little bit. If I had said, echo, today is date, right? So that takes the output of date and it replaces it as if it had been assigned to a variable right there. Okay. But think about what prompt was doing. Prompt is trying to replace this thing with its output, but the output it's got two outputs. It's got the output that waits around for me to type something in, and it's also got the output that is the actual thing I typed in. And that's the problem. The problem is that's why we get the magenta prompt as if I had, made it a part of the string. And so what we're doing, normally redirecting standard error and standard out or not, this is not what it's done. It's usually because you don't want to see all the error messages. But if you can get your head around this, and it might take you a while, but if you can get your head around what is actually happening there, you will perfectly understand standard error and standard out and standard input redirection, because all three of them are there. All three streams are in that example. Can you name them? All right, so let's go back and name them, right? This is kind of a good way to quiz yourself. What, my friends, what is this here? Okay, so printf, where is that going? Where is that prompt, that magenta prompt and that little prompt thing? What stream is that going to? What stream of data is that going to? Standard output, right? What stream is being read to go into the line? Standard input. Okay. This is reading from standard input. The input is what people are typing in, what's going into the program. Yeah. Yeah, read standard. Okay, and then this one, echo-n, that just says don't put a line return, reset. So this is sending a special ANSI escape for resetting the color to what stream? Standard output. And then this echo the line that we read from standard input, we're going to echo it back out, and we're going to print it to, echo it to standard output. So we have one line of standard input, whatever we typed in, and we have one-ish lines and 2 lines of output. And that's what we end up seeing here. Hello, comma. Now the reason the hello actually comes from the echo. So prompt actually has this as 1 line of text that comes out of it, this, right? So what we're going to do here is we're going to cheat, and we're going to use standard error, which is designed to be throwaway. Standard error is designed to display to the user, but to have it be disposable. It's supposed to be disposable. So now what we can do is we can say, I want to make this disposable, and we can say, I want to redirect the default to 2. And there's actually 2 ways of doing this. You could do it either like that, or you could do it like that, either way. Now, quite honestly, usually when you're redirecting output like this, you're redirecting it to dev null, which says don't print it out at all. Nothing gets to see it, right? So, and 0 is in standard input, 1 is standard output, and 2 is standard error. And those numbers are always the same. Those are the same file descriptor numbers. So you can actually make new file descriptors. I found out a while ago, but we're not going to get into that right now. So we're going to redirect our output to standard error instead. And then we're going to do it right here. Now, is that a beginner content? I don't know. Probably not. But I do feel like it's a pretty solid way to illustrate what the 3 streams are doing, because, you know, hello there, prompts, Rob, right? Now since we're at this, let's go files and streams work. Yeah. So, we only really want to think about those 3 streams right now, because they're going to pop up all the time. You're going to use, if you're using the terminal, you're using those 3 streams constantly. So wouldn't it be great if we could put something else here instead of it just being the prompt? What if we could also, let's go back to this one. Whoopsie. What am I doing? AP. Use empty. Rob. All right, there we go. So what if we wanted to actually say something more, right? Let's say I want to say something more. Let's say I want there to be more information here. So we could say, we could actually print the prompt. So we could say, let's say text. How about that? Text equals, and we're going to put everything from the command line into a variable, and we're going to say, and now we're going to print it out. So we can say text. All right. Now we should probably do this instead. Do we want it to be on the same line? Yeah, let's do that. Let's do that. Let's have it be on the same line. S here, instead of having magenta, then we're going to have text. Now I could have just done this, right? So, yeah, let's actually do this instead. Yeah, and it could be empty. So let's try that. Now let's do our thing again. Hello there. Okay. Oops. Okay. See how I said prompt, but let's actually change it. Say prompt, name. Name. Now it says your name. It's like, what's your name, right? Rob. You can say prompt, what is your name? And it'll do it. Okay. If it makes you feel safer, you can put quotes around that, You could say this, you could say, what is your name on, and here's where it gets funny. What is your name on this date? You can actually nest these things. Rob. I know there's a lot happening there, kind of on purpose, because I want you to do. This is where the power starts to come in of shell, because you can intermix things with each other, and we haven't even gotten to pipes yet, right? We haven't even gotten to pipes yet. So you can actually make these like things that are composed of other things. And that's where things get really, really powerful. Um, so you could have it be, you know, you could have, instead of being date, you could have it be, you know, um, you could have it be anything. You could have it be, you could have it be literally anything. You could have it be like, you know, I mean, you could get rid of prompt. You could have it be BC. Well, anyway, I'm getting ahead of myself. So anyway, prompt Rob. All right. So hello there, Rob. Now, what we did is we just made ourselves a reusable prompt command. Now that command can be used any place that we ever want to prompt for input, ever. So from now on, in perpetuity, in the Unix philosophy, I now have a command that I can execute, and I can make it do anything. I can run it by itself. Prompt, what do you want to do now? A question mark. It's like, hello. You know, we should probably get rid of the question mark in the prompt, because it might not be a question. It might be a action or something, right? So let's get rid of that. Whoops, let's get rid of that part. And then, so what do you want to do now? Right? Let's put a space after it. That's probably wise. Prompt, what do you want to do now? Whatever, right? Now you could actually put, like if you want to get crazy with the color. The thing of it is, we're not going to have to do this again. We only wrote it once, and then we're going to reuse it all the time. So you can like really get nice, you know, fixing it up and stuff. Let's actually make it a different color, shall we? Let's make it black, which is not as prominent. I think black is 0. And we could actually just use the numbers if we wanted, but the videos aren't lagging. The videos aren't lagging. Yep. There hasn't been any lag so far in this video. Yeah. We already redid. You weren't here when we redid the whole thing. I'm not going to talk about it. We'll talk about it during the break. I reset my entire modem, and I ordered a new one. So if it's still lagging, I can't help you guys. It's upstream, 100% upstream. Yep. Okay. So there's a prompt in there. It's kind of hard to see, but it is there. You know what? We could probably just remove it completely. How about that? We really don't need it. We don't need it. Let's just get rid of it, because we can put whatever the, you know, hello. You know what I'm saying? So prompt, blah, blah, blah. Now we have this nice happy thing that we can use all the time when we want to, and we can do some other coding with it. Okay, so that was the point of that. The point of this is that we are doing this the Unix way. We're making one command that does something useful that we can regroup together and combine with other things. And I started doing this by putting them into functions, and that's very much the Python or JavaScript way, but it's definitely not the Unix way. The Unix way is to make them all into commands that then can be composed together in all kinds of creative, interesting ways that are not dependent on everything being in the same file. So this is very much a different approach to it from, you know, Python or JavaScript or Node or whatever. And that's those tools would have you, you know, want to use one of their specific plugins or function libraries or something, because you'd have to do that. And when we get to coding in Go, you'll see that that's a thing. In Go, it's more about, you know, making a bunch of a reusable function library or procedure library than it is about creating a bunch of independent commands that can do really amazing, cool things. So, but I really want you to start down this path properly with Bash by making, you know, one or two commands that do one thing really well. All right. So what do we got now? We're now on to the next thing, and we have another 30 minutes. Okay. So far we haven't made anything really substantial, but we've learned about variables. We've learned about, you know, we've learned a little bit about conditions. We started to learn about conditions, but we kind of sidetracked on that with case. So now what? What's the next thing we're going to make? We've also talked about functions, but instead of talking about functions and procedures, what I'd rather you take away from this is I'm going to make a command that does something. That's way more valuable for Bash than understanding how to make a function. And I hope I haven't beat that to death. but it's critical that you understand why that's a significant difference. All right, so you can kind of, if you've done programming before, you can think of these commands as procedures or functions wherever you want, because they're essentially the same thing. All right, so now it's time to start doing something more fun. Let's actually take our randomness. We have our random color. We've got a whole bunch of really great things that we've done, so we can start assembling our things together to make something interesting, or just fun for today. And so, what could we do? Let's do Nyan Cat. We already did that. Let's make a very stupid, simple program that does Nyan Cat. And if you know what Nyan Cat, it just continues to repeat things. Okay, let's actually make one. So again, the point of this is repeating the steps over and over again so they stick in your head. Chat from let's see, is it Streamlabs? Comment on Twitch chat from Arctic Shrub. No, it's a bot. It's a thing that's copying it over. It's a bot that's copying over. Yeah, Streamlabs is coming from my bot. Okay, so it's coming from my bot. Yeah. All right, so here we go. We're gonna go ahead and now we're gonna put some stuff together. So let's just make something silly. Wouldn't it be fun if we could make that repeat, right? So you can actually start playing around with this. What if we did this? Rand color fun. What if we did this? While true, do that sleep for 0.1 and then do it again. So now, it's a thing, right? That's kind of cool. What if we did, instead of rand color fun, it's actually not putting it on its own line. It's like, but like, what if we did that and we wanted it to be on the same line? Let's see if we can do that. Echo dash n. I'm going to see if this will fix it for us. Yep, there we go. So the thing to take away from this is that when you make, this is actually happens for you automatically. When you put a command inside of a parameter, a variable, a subcommand shell like we did, it actually takes the line return off of the end for you automatically. So that's what we just did with that. So what if we could put that into a program? My friends, this is the best part about shell. I'm going to use tmux, and I'm going to take that one-liner that I just wrote, and I'm going to put this thing inside of a script. So I'm going to open up a script. We'll call it Nyan. And I'm going to paste it. Oops. Paste it in. Oh, God, Rob. Paste it in here. We give it a shebang line. And honestly, we don't need more than bin.sh in this. So we're fine. Bin.sh and bin bash. Bin bash if you can. But in this case, there's nothing new going on here. So, we have our random color is already covered by bash. So we don't need anything more. We can just use regular old bin.sh. And we can do the echo right here. Put our sleep in here. And quote this to prevent word splitting. Okay. So let's go ahead and do that. And we can say function find color. We can say nyan. And positive sh echo flags are undefined. Oh, remember I was telling you about echo doesn't do sh. This is good. This is good. You see how shell check caught it for me because it saw the bin.sh as POSIX shell, which is a limited shell version. It's not bash. So I can either change to bash and get unnecessary overhead, or I can keep it in bin.sh and I can change it to printf. Okay, but then it's going to complain because it's like you can't do substitution. Yeah. So then we do this. We do s and make it happy, and we put this over here and call it a day. So again, the %s is where the thing gets substituted. And then that's 100% perfect shell script. We talked a little bit about bash versus POSIX sh. This is one of those cases, but you see what I'm saying by composing them into single individual commands. The commands that need bash can use bash. The commands that don't need bash don't necessarily have to use bash. And while it's nice to default to bash, it is kind of nice to do that. Yeah, there's been a little bit of video stuttering. Yeah. It's no longer happening. Only about 3 times a day. Okay. Yeah, we're having packet loss right now, big time too. And I don't know what's going on with that. I can't solve it. So anyway, so now we're gonna go ahead and do it again. So okay, I can't run it though. Why can't I run it? You guys remember? Why can't I run it? What's wrong with that now? Why won't it run? We're having massive packet loss. Yeah, I don't think the packet loss is because of me now. I don't. Yeah. Yeah, we need schmucks, right? We need permissions, right? So we need schmod plus x, schmucks, or schmod plus x, which is just an alias. It's just hard to type. And so I don't type it very much. I am not uploading anymore now. Uploading is over with. Yep, that's done. All right, so nyen, and now we can run it. But you see how I didn't have to do dot slash? Why didn't I have to do dot slash that time? We already talked about this. This is, I think it's a video you missed, YouTuber. But that is what we did when we figured out path. We spent an hour talking about path and how to do it safely. And then, so we're going to do nyen. And you can actually adjust the speed on that by setting it up to a little bit faster. We could say 0.005 nyen. Or you could say, it's funny you can do is you can actually keep it in the same directory. In the same directory as the script. Yes, but we've also added this to the path already. We did that earlier. So I just want to let people know. So there we go. I mean, that's pretty fast. It's almost like a terminal tester. Yeah, it's kind of garish, but whatever. 3, 2. Yeah. So the folder is in my path. We did that earlier. Yep. I showed you guys how to do this, and it's in my bash RC. I showed you guys how to add it to the patch. There it is. And we did that thing with path, and we talked about how don't screw your path up, etc. So we covered that already. So that's it. So let's continue down this path, lol. We just doing a loop. So the first loop to know is while. And what while does is when this condition is true, it continues it. And there's 2 keywords, true and false, that you can use. As we're done here, true is obviously always true, so this is an infinite loop. But now there are other conditions where it might not be true, right? So you might want a condition where it's true and one where it wouldn't be, right? So you can already think of some things you could probably do here. And those of you who know about for loops, just please stay tight for a second. I have a plan, okay? So let's say we only want to do it 10 times. Intuitively, what would you do? Intuitively, you'd say, well, okay, we need a variable. So let's add one. So we say n. So we say n equals, or you could say count if you want. It's up to you. Say count equals, we'll start with 0, right? It says count is unused, verify is a thing. Okay, so let me say, well, count is, less than, and this is where the difference between bash and shell start to get interesting. So while count is less than 10, there's a much easier way to do this, but I just want to show you this. So while count is less than 10, keep doing it. You can already tell shell check is yelling at me. It's like, what the hell are you doing? Right? So it's like, this is a file redirection. This is not less than. Was it supposed to be something else? Because there's no such thing as that. So if we're using POSIX shell, then we need to do this. We could say less than 10. All right. But then it's like, is that a thing? Right? Well, is it still going to go forever? Account appears to be unused. Well, it's not a variable. You need to make it a variable. Okay, now it's a variable, right? So while count is less than 10. And unfortunately, I'm going to have to show you many, many ways to do conditions because you're going to encounter these all over. You're going to see these kind of conditional things where the operator is less than is a dash, and other ones where it's an actual less than. And I want to show you both because you're going to see both a lot. So we're going to run nyen. What is it going to do? And that's going to do anything. Because why? It's like there's no such command as that. Like, what the hell are you talking about? Wait, what? Line 4. 0, 1, 2, 3, 4. All right, so line 4, there's no such thing as count because it's not a count, right? All right, so this is a condition. So we actually have to put the condition inside of something else. I'm going to do something that might be a little strange to some of you who've done shell in the past, but watch this. All right, so if I do this, it works. And I'm doing this on purpose. I'm deliberately doing, a bunch of shell people just like lost their minds because they're like, why are you showing them that? Because this is what's actually happening when you do shell. When you do shell, you're actually running a command. In POSIX shell, you are running a command. And hear me out. This is the way to learn this. Okay. So it said that there was no command before. It said there's no such command as count. No, it's fine. Do you see any double brackets or single brackets? There are none. And it works. Why? Why does it work? I really, really want you to process this. If you understand why this works, you'll understand shell better than 80% of the veterans that I've worked with in the professional world. It doesn't have to have a bracket. Why? Because the condition itself is the execution of a command. My friends, in a sense, actually test doesn't even work. This is going to blow your mind if you don't know this already. In all modern shells, but in the original shell, you remember we talked about things being passed into, all the arguments. So what this is doing is it's running this is the program, and each of these is an option that's passed into the program. That's why it's -LT. The reason that it's -LT and it's -GT is because those are options to the test program. I guarantee you there are veterans that you will run into who have no idea what I'm talking about. The -LT is an option to the test program. And the count variable, is the first argument to the test program. And the last argument to the test program in this case is the 10. Okay? So what is that actually doing? So what that's doing is it's running a program. Okay? And the return value of the test program in this case continues to be, we haven't got to return values yet, 0 and 1, but in this case, it's 0 every time until it's not. So what you'll see people write, and this is what you'll see people write, but I want you to understand it's the same thing. Why is that important? Because when you're looking up how to do conditions, this is how you do it. Man test. This will tell you everything you need to know. The test program is what you're running. Now, is it true that modern shells have built this into the shell itself and they're now built-ins? Yes, that's true. But it's really important that you understand the origins of this, because you will find shell systems where this is all there is. And it's super important that you understand that this is a separate command. Test is a separate command. And this left bracket is actually a command. You can actually find it with the path command, and it'll show you right where it lives. Now, there are so many people that do not know that. Yeah, the required space after the bracket was so weird for me, but that is why, and that is why, Cookie, that is why I'm telling you about this. The reason for the really weird have to has a space in between them all, the reason for that is because, as we just saw, every one of those things is an argument to the test command. And the only way to separate arguments passed into the test command is with a space. That is why a space is required. I guarantee you 90% of the admins have no idea why spaces are required. They think this is a stupid syntax. Why is this that way? Now you know. A lot of people do not know this. A lot of people. And you know it. Now you know it. Even if you don't care, right? You're just like, I'm going to put a space there because someone told me to. Now you know why. And you can explain why to somebody else. The thing that's really crazy about this is that the second bracket is an argument that's passed to the test command. How's that to blow your mind? The closing bracket is not part of bash or shell. It is an argument. It's an argument. It's one of the arguments. So the first bracket is the command, and the last bracket is an argument that signifies the end of the arguments. That is why, by the way, this is also why you get these really, really, really weird. It can't, I don't think it can be. Can it be? Can it be omitted? I think you can definitely omit it with the test command. That'd be interesting. Is that a thing? Expect test to end here. Don't wrap. I don't think this is gonna work. This is super curious. Yeah, it doesn't work. Yeah, so no, if you're gonna use that format, it doesn't like it. So, but you can use test. And let me tell you something. A lot of times code is much easier to write with the test keyword than it is with the brackets. And it's easier to read too, particularly when you start getting into short circuit logic, which we haven't done yet. When you start doing short circuit logic, not using brackets, double or single, starts to make a lot of sense. And it's a lot easier to read. So I'm just letting you know that that's a thing. After the second bracket will be another argument. Yeah. So yeah, you can. So having said that, you can replace this. This is POSIX shell. So we're using single brackets. You can't use double brackets in POSIX shell. By the way, what is that? That's a mistake. Why? Because it has to be an argument. Again, I switched gears on you. I'm now using POSIX shell instead of bash. That's why there's single brackets. Using single brackets in bash is a mistake. Absolutely. It's a total mistake. Unnecessarily verbose, completely unsecure because of expansion, which we haven't got into. If you're doing bash, use double bracket or test. If you're using POSIX shell, use test or single bracket. Don't use single brackets in your bash. Please just promise me you won't. There's no need for it. So now you know the difference between the two shells. So you've got, this is the same. This is exactly the same as the other one. Exactly the same. Okay. Now the difference here is, and I'm going to make this bash for 1 second because I want you to see the difference. But when you make this into a bash script, and it can be bin bash, which is version 3 of bash if you want for now, that code will work. That code will work. No problem. But this will also work, which is safer. And what else? And this will also work, I think. Oh, wait. Oh, no. Wait, I mean, we have to do the math thing. Yeah, I forgot about that. Yeah, never mind. I guess that's the only one for that. Yeah, I'm mistaking something. You could do this instead. Yeah, so this does mathematical comparison. And when you do this, you don't need this, and now you don't need the space, which I just blew somebody's mind. All that shit I was just saying about putting a space there, when you're doing math, it doesn't matter. When you're doing mathematical comparisons, it doesn't matter. In fact, it'll even, you don't even need the dollar anymore. Okay, so that if you're doing a mathematical thing, you can use the two, instead of two brackets, you can use the, I don't think this is a shell thing, honestly. It's really not. Math in bash and math in POSIX shell are totally different, and I really don't want to go down that rabbit hole right now, but I'm going to try it anyway. Yeah, you can't do it. Yeah, there's no such thing. Yeah, so only bash has got the mathematical operator, which is why you would want to do that. Okay, so, and to tell you the truth, you're going to want the mathematical operators. This is kind of an interesting point at which, do we, oh, is it two from POSIX? It has to have it. All right, let's try it. Remove the dollar to avoid, what the hell is this about? Shell check is like giving me all kinds of stuff. Oh, what the hell is that? What the heck is that? That's what shell check tells me to do. No wonder I've never used that. I don't use that. I don't like, this is why I use bash, because it's like, we start out learning bash and we're going to keep learning bash from now on. But the second bracket becomes a closed argument for anything won't get past this argument. Yes. So apparently in POSIX shell, the only time you can use this syntax is as an assignment. And, so we're going back to bash. We could user bin env bash. This is going to be slower, but we're learning bash is the first thing. But if you want to go back and look at all the other stuff, you can. Now you can either do this, or you can use the test command, or you can just use math. The math is a lot faster because it doesn't. I'm catching myself because both of these shells no longer shell out to run the test. They used to. So anyway, so there you go. There's your count. It equals 10, and then you got your thing, right? Okay, but how do we increment it? How do we increment it? So let's actually increment it. So we need to make it bigger. So we're going to say count equals count plus 1. And that's a thing. All right. So, but I'm going to comment it out because that's kind of a waste. You can do plus equals 1, which is also a thing that says add 1 to it. Right? Or you can say plus plus, which says just add 1 to it. They're all the same. All three of those are the same. So put those in your notes. Okay. Now let's run it. Now we run Yancat, and it just ran 10 of them and stopped. Okay. And it ran them really fast, but it stopped and only ran 10 of them. All right. Now we're gonna wrap up the today with one more version of this. Okay. And I want you to see this. All right. This is init, initialize a variable, right? All right. This here is check the variable, check the variable against a condition. Okay. And then this down here is the change the variable in some way. You can probably know where I'm going with this. All right. This is really, really important. I want you to see this, what we're doing. Okay. So, and the next thing we're going to finish is the end of looping. And the last thing we're going to do is functional recursion, but we'll wait on that until later. So in fact, we're probably not going to do functional recursion until we get into Go. There's no reason to do it in shell at all. All right. So what have we done here? Now, wouldn't it be great if we could put all of that into one line? If we could put all of that information, all of that stuff into one line instead of having it spread out all over. Like, especially like in this while loop, right? In this while loop down at far at the bottom, it could be off on the page. It's like, I can't remember what the condition is and stuff. Wouldn't it be great if it were all on one line? Well, every programming language on the planet pretty much supports that alternative syntax. So what I'm going to do here is I'm going to comment all of this code out using a technique, which is kind of fun. We're just going to do this, right? I'm going to put an EOM down here. Now, what did I just do? Make sure you put that in your notes. I just block commented out that entire thing. That code is not going to run anymore. That's why it's green. You can use that for comments. You can use that for commenting out huge blocks of code. A lot of people don't know that. You'd be surprised how many Unix people do not know that you can do that. They will come up with all kinds of convoluted things, and they will put they'll create, they'll do visual mode, and they'll put comments on the whole thing. If you just want to turn off a whole section of code in shell, that's what you do. I just did it. All I did is I turned it into a big old string, and I told it to do nothing with the string, and that's what this is. Will rand color run? Yes, absolutely. Now this is off. No, it won't run. Nope. Here, watch. So let's try it. See? I mean, actually, I think it does run. Good point. I think it does actually run because this is You know what we could do? This would be even better. How about that? You know what? That's a good catch. Good catch. Because it was embedded. So it actually would have run. Yeah, good catch. Good catch. That was really good. Thank you for that. So, and you know what? We kind of got a hint about that because it was still showing. So, you know, color matters. Anybody who ever tells you color is juvenile, that's a direct quote from somebody. Color in this case shows you that, hey, something's not going on. Why is that? Okay, we're going to get to this later, but that's because you remember how you can have strings with either double quotes or single quotes? When you have double quotes, it doesn't do the things inside. I'm sorry, when you have single quotes, it doesn't. When you have double, it does. So it's still trying to do the thing there. So I think, so we're going to go ahead and put double quotes around it just to be clear. I mean, single quotes. And that's going to say, hey, I want all this stuff to be single quoted instead of double quoted. There's one other thing you can do here. You can put a dash, which we'll get to later, but that actually automatically indents everything. And I don't know if you saw, but it automatically did it for me. And it does it with tabs, which are the standard. Tabs are the standard in shell. Initial tabs are the standard. If you're using anything else, you're using non-standard stuff. I'm not making the rules. That's the official. That's why SHFMT reformats with tabs. And you can fight me till the grave on that. I don't give a shit. That is exactly the way it is. If you're using anything but tabs, you're not writing shellcode. You're not. Because this dash only works with tabs. It doesn't work with spaces. I didn't make the rule. I'm just reporting you to the rule. Okay. So there you go. You know how many people don't know that? Pros that have been doing this for 40 years, they will put spaces in here and think it's totally fine. And they'll get mad at you for putting tabs there. They'll yell at you for putting tabs there. And you're like, really? Because the SHFMT tool uses tabs. I was one of them. I got mad at a newbie on our team. I was like, why are you putting tabs in there? And he said, well, that's what SHFMT does. I'm like, what? He goes, yeah, it must be the standard or something. And then I looked into the dash and I was like, I know it's standard, but I hate it. I was wrong. And he's like, no, you don't need to do that. Don't do that ever again. And I'm like, I never have. So, and besides, if you're auto formatting, who cares? Who cares if you're doing SHFMT and it's automatically formatting? If you don't know how to do that, by the way, it's all in my MemRC. Programming with syntax highlighting seems masochistic. It's not masochistic. It's more efficient. Yeah, not having syntax highlighting is dangerous in 2024. And all of the people who say that all they need is black and white, the only proper response to that is, okay, boomer. Because I have caught misconfigurations in production SSH configurations because I had color. And the guy who set it up, who made the production mistake that almost took down our system, didn't have color and he didn't see his mistake. Had he had a syntax highlighter, he would have seen it in production, in operations. So I don't want to hear that shit anymore. If you're going to push black and white terminal on me, that's all that anybody ever needs, great. You do you, but it's stupid. Okay, so anyway, here we go. Oh, did you say without? Oh, I'm sorry. Then thank God it's not there. Programming without syntax highlighting. I didn't mean to go off on you. I didn't read properly. All right. Actually, I did. I'm glad you heard that. So anyway, in 2024, not having syntax color and saying it's juvenile, that's a direct quote, by the way, from a very important person who created Unix and stuff. You know, whatever. They're fine. Anyway, let's do something more productive. We're about done with this. We're about done on an hour here. And what I was trying to get to you is to this part. This is the main part. We can rewrite this in the same code in one line. In fact, we don't even really need to change all of this. But instead of this, okay, we're going to do, oh, by the way, here's another trick. You ever want your shell check to shut up? Just put a no op in there. A common no op. That's what that is, or a colon no op. Okay. Okay. There is no count. Okay. Let's refer to the count. Let's change it from a while to a for. And now we're going to say while count equals 0, semicolon. And then we're going to have count plus plus. Oh my Lord. What just happened, right? And now we can take the rest of our code and put it in here. Put those two things in there. You know, and And that's it. Now I had some other code in there for fun, but so here we go. That's it. Now that does exactly the same thing. So nyen, and we run it. 10 repeats. There is one other way to do this that I'm going to show you before we leave. That's a bash only way. But what I want you to see here is this. This is the takeaway from this. Init check change. Init check change. Init check change. Say it 10 times. Init check change. Init check change. Init check change. You know how many times in my career I've forgotten the order of these? The most common mistake I make, and I'm a little dyslexic, I still make this mistake, is I can't tell you how many minutes, maybe even hours, that I have lost with some stupid mistake because I put the change in the middle instead of the check. I do this all the time, and I'm going to blame my partial dyslexia on this, but I will do basically init check change, init check change. The middle one is the check. The middle one is the check, and the last one is the change. And I have swapped those so many times, and it runs. It runs, but it doesn't do what I think it's going to do. And I'm like, oh my God. All right. But the takeaway from this is that these two loops, this is what these are called. These are called loops. These two loops are identical. They're identical. They do exactly the same thing. So much so that the Go language doesn't have a while keyword. It only has a for keyword. Because Rob Pike's like, why do we need that? It's just wasting time on the compiler. I don't need it. I can just use for instead. And we're gonna get to that. We're gonna code and Go later. But for right now, I want you to see this. So you've got a while loop or you've got a for loop, right? You can do both of them. And by the way, this is the same for Python, Ruby, Perl, JavaScript, Rust, anything, Java. They all have the same idea, right? And again, and by the way, it doesn't have to be numbers. Init check change. Initialization, checking for a true condition. And it doesn't have to be a number comparison. It could be anything. You could check to see whether a variable had something in it or not. And then the change. What is changing? Is in this case, it's always, adding a plus on there. In C++ code and other things like that, you'll see the use of plus plus or minus minus. Minus minus decrements it. So you'll see this too. You could do this exact same thing like this. And you could say is greater than 0. And then you could do count minus minus if you prefer. It's up to you. It's the same thing. Same exact thing. Okay. So, and you can do it you can jump by 2 if you want. You can say, if you want to do evens and odds, you can actually do modulo 2 to say, I only want to print on the odds. You could do the same thing. Let's say you had like 10 lines and you were going through all the lines. You could print only the even ones by making the condition modulo 2 or something, or actually having the count condition be whatever, add 1 to it, and then the condition would be mod 2, and then it would only print the evens or only print the odds. There's just a myriad of possibilities here. This is why you're learning loops like this. There is one last loop before I'm going to end this video, and this loop is exactly the same as this loop. And I'm going to, I could just CMT that. That's fine too. I don't care. See, I'm kind of, either way is fine with me. There. Okay, so this is a bash only thing. A lot of people don't know this, and it is really, really useful, especially from the command line. So you can do this. 0, let's say I want to do it 10 times. So I want it from 1 to 10. Or you can do from 0 to 10, right? From 1 to 10, do echo. Let's do I in 1 to 10. We're going to get, there's another thing for loops can do is they can iterate over the things that are there. And that's going to happen later. We're going to have to do that probably next. But what we can do here, done. So, yeah. So it's just going to, output the number. And this is, of course, this is an Nyancat. But it'll do 1 to 10. And so here we go. You can do for that. So actually, if you want to do that, you could do 1, and then you could do nyen. Right? You do 1 and a nyen. And then you can say, oopsie. Wait, what am I doing? I just recursed myself. That was horrible. Rand color. I did recursion on myself there. Yeah, bad me. All right, so do that. There you go. There's 10 yens. Yeah. I like the 4x and command looping. That's also a thing. Yep. But that's backtick, whether it's backtick or that. Yeah. Okay, so there's another way to do this. So the POSIX shell way of doing this is this. So there, I mean, you can put all these in there. Well, let's do this. Turn this on. If you want to know how to do the incremental number thing in POSIX shell, use the sequence. This is a subshell that you do seq to 10, and that will give you 10 from 10 to whatever. Same exact. Oh my god! Did you see it fixed my thing? It got rid of my backticks. SHFMT replaced my backticks. These are all getting recorded. Yeah. So it replaced my backticks. These are the same. This is POSIX only. So if you've only got POSIX shell, then that's the thing. This is bash only. Bash only. POSIX shell. So, you know, there's lots of things you can do here. Or you can do this like the really long-winded one. And there's, you know, lots of different ways to loop here. We're going to do iteration. Iteration is kind of a different thing than numeric counting. So we're going to save iteration until we can go over, you know, lists and stuff. And that'll probably be the next video. So we'll do another video after this. But yeah, so this is all saved. Remember how to save it. Let's go ahead and save it. Git add dot git commit dash m add nyan prompt etc. And then we want git push. So that's how you save your code if you haven't done it. Gh repo view dash web to open it up, and you can share it. If you want to go to artifixrob/lab-sample. For now, I probably will archive it, which means it won't appear in my list, even though you'll be able to get to it if you know that address. So I'll leave that there for a while, and you can go look at that. My wife is not home yet, so I'm gonna go ahead and make yet another video, and we're gonna finish the looping and the iterations over things. Now we have indirectly covered types, and so there's 2 more complex types to cover. And after we cover that, you pretty much know everything. Everything that's necessary to make a bash RC really amazing. And then the final video will be us going through the bash RC file itself, and then you can see all the stuff that's in there. We do have to do complex conditions, which we have not done yet. We have not combined more than one condition yet. We have not done short circuit logic. We have not done, you know, that's it. And then of course the iteration stuff. Those will be the looping techniques that we have to use. And honestly, that is it. We've done. You know how to do math. You know how to do recursion. You know how to do most everything. And that's enough. That's enough for pretty much any dynamic configuration. We're not going to do a truth table, no. So you know, whether you're doing a configuration in Lua or you're doing a configuration in for NeoVim or WesTerm, or you're doing like a bash RC configuration or anything, most of the things that have dynamic configuration of any kind limit themselves to the basic logic of procedural programming that we've been doing so far. This is why it's such an essential for the beginners to learn this stuff, because not only is it what you do every day when on your command line, but it's also the same idea in other dynamic configurations. And after we finish the bash RC thing, the next thing we're going to do after that is going to be JSON with JQ and YAML with YQ, and potentially Tom will talk about that. And then the next thing after that will be Go. and that's going to cover it for this holiday boost. All right, so I'm going to take another break. I'll talk to you in a bit if you want to hang out with me. I'm just going to keep knocking these out. The reason I want these to be around is I want people for the next several months to be able to go redo these and feel like they're getting something out of them while I'm working on the book and thing. Talk to you in a bit.